Today we're looking at solving systems of equations using the substitution method. Here's my system of equations, two variables. The solution to this system is going to look like an ordered pair, x and y, that solves both equations at the same time, that makes both of them true at the same time. First thing I'm going to do is solve either equation for either variable. There's a lot of freedom here. However, having said that, make your life as painless as possible. If I picked, say, the second equation and wanted to solve it for x, at some point I'm going to have to divide by -3, and then I'm going to have 2/3 y. It's not that fractions are evil, it's just that whole numbers are easier to deal with. So if I can avoid the fractions, I would like to. Here's what I'm going to look for. I'm going to look for a variable that has a coefficient of 1. Like y in the first equation. So I'm going to take my first equation and solve it for y. I'm going to subtract 2x on both sides. So I have y equals -1 minus 2x. No dividing involved. Nice whole numbers all around. There we go. Here comes the substitution part. Now I have an expression for y. Y equals -1 minus 2x. I'm going to substitute that into the other equation, and I cannot emphasize enough how important it is that you use the other equation, not the same one. Otherwise you chase your tail and you don't get anywhere. So the other equation, I'm going to substitute that expression in place of y. So I'm going to put it in right there in my second equation. I'm going to rewrite that second equation someday. Here we go. -3x minus 2 times, and instead of y, I'm going to put this expression that we have for y, -1 minus 2x. Those parentheses are really important. And then we'll finish out the equation, equals 0. Well, now I have one equation and it has all x's, one equation, one variable. We know what to do with those. We're going to solve that in the usual way. I'm going to distribute. So I have -3x. Let's see, -2 times -1 is +2. -2 times -2x is +4x equals 0. Combine some like terms, rearrange a little bit. And I have, let's see, 1x equals, no, that's nice, we're done. X equals -2. If we only had one equation, we'd be saying, cool, I'm done. But we don't. It was a system of equations, which means we also need a value for y. Conveniently, I have this expression right up here that says y equals -1 minus 2x. I can use that. Now that we know the value for x, y equals -1 minus 2 times x is -2. Multiply, combine, and I get y equals 3. Now that I have a value for x and a value for y, we can write the solution to the system of equations as an ordered pair. X is -2. Y is 3, and there it is. We're done.